Hey folks, welcome back to example 6. So I'm going to graph the system of nonlinear inequalities. And I say nonlinear because I've got an x squared term. This is a line, this is a parabola. So we're going to see where does the line and parabola meet possibly, and then where's the feasible region. And just things that I'm taking note of before I even get going. When I graph the parabola, I'm going to make a solid line because I want to include y equals x squared minus 1. And when I graph the line, I'm going to make a dotted line. All right, so if I think about these as equals, right, this is y equals x squared minus 1. It's our toolkit function of y equals squared shifted down 1 unit. If I solve this equation for y, right, if I rewrite this as x minus y equals negative 1, but I solve it for y, I'm going to get y equals x plus 1. Right, so here I have that parabola. Here I have that line. So I'm going to see where does this parabola intersect the line, or actually, where does the feasible region occur when I have the shading for the parabola and the shading for the line overlap. But before I go figure out the feasible region, you keep, oops, and I can see my focus is kind of messing up on my recording device. I'll try and keep my hand there so it can stay focused. Before I go and shade over test points or not, I'm going to figure out where the intersection of these two equations are. I'm going to actually pretend this is a system of equations and solve that and then use that in my graph. So I'm just going to do some side work here. I'm going to go ahead and think about when is y equaling x squared minus 1 going to overlap or intersect with y equaling x plus 1. And I'm going to go ahead and I'm just going to use substitution. Right? If both of these things are equal to y, then they're also equal to each other. So if x squared minus 1 equals y and y equals x plus 1, x squared minus 1 must equal x plus 1, right? These have to also be equal because they're both equal to y. So if x squared minus 1 equals x plus 1, well then I can go ahead and set that quadratic equation to 0. So I'll have x squared minus x. If I move the other one over, I'll have minus 2 equaling 0. Anytime you've got a quadratic equation, you can factor, complete the square, quadratic formula. I'm going to factor. And then I can see I have two zeros. I have one at 2 and one at negative 1. And that's great, but I need ordered pairs, right? If this is going to help me with my graph at all. So let's see what happens. I'll start with negative 1. All right, if x is negative 1 and y is x plus 1, right? Y would be negative 1 plus 1. Which would ultimately be 0. So I know I'm going to have an ordered pair at negative 1, 0. All right, and then let's see what the case is when x was 2. If I substitute that back in, y would equal 2 plus 1. Whoops, you can tell I thought of the answer and then I wrote it. 2 plus 1 is going to be 3, so that tells me I also have the ordered pair. Oops, and I can do this. Sorry, the x coordinate's 2 and the y coordinate is 3. Okay. So I'm going to go ahead, I'm going to draw my line, I'm going to draw my parabola, and then I'm going to pick some test points and figure out what my feasible region is. So let me go ahead and sketch this. All right, we can see all of that, and we can see all of this. Okay. All right, so it looks like I had ordered pairs at negative 1, 0, and then 1, 2, 1, 2, 3, right? Now the line needed to be dotted. Oh, and I'm not scaling this, so let me put a 2 here and a 3 here so we can see it. But I'm going to dot this line. All right, oops, I guess I didn't dot in the middle. Give me a moment. Okay, there we go. And it does have this line, right? X plus 1 has a y-intercept of 1 and a slope of 1. So I go start at 0, 1, up 1 over 1, up 1 over 1. Okay, I need to either shade above the line or below the line. I just don't know which. Oh, let me scooch this up just a wee bit, just so we have that. All right, let's figure out a point that's not on this line. I'm actually going to pick the origin, right? 0, 0 is not on there. So let me use this test point and I'm going to test out the line, right? Test point of 0, 0. All right, Let's try. Is 0 minus 0 greater than -1? I'm going to put a little question mark over that. So I'm going to solve this inequality. If it's true, I'm going to shade over 0, 0. If it's false, I'm going to shade the region that doesn't include 0, 0. All right, 0 minus 0 is 0. Is that greater than -1? It is. So I want to go ahead and shade here. I'm going to do it lightly because I still need to make another graph and I still need to do one more inequality. Sometimes I just kind of mush it out. All right, so you can see, hopefully, maybe that's too light now, that I shaded below the line. Maybe I mushed it too much. This is about as arty as I get. All right, can we see that? I don't even know if you can see that. Does that show up on the camcorder? Now I'm gonna do this a third time, as you're probably forwarding a little bit. All right, so in a moment, I'm gonna graph that parabola, okay? Now that parabola starts down here at -1, and because I have a greater than or equal to, I am gonna put a solid line. And I know it goes through -1, 0, and 2, 3, so I can actually just sketch this, right? There we go. Now, I either need to shade above the parabola or below, so my feasible region will either be this little part here, or it'll be this wider part here. I'm not sure which. But let's try this again. So now let's try this test point of 0, 0, because 0, 0 is not on the parabola either. So let's try this. Is it true that 0 is greater than or equal to 0 squared minus 1? Okay, I always put the little question mark over the inequality. We'll see. If it's true, let's say this is true. I don't know yet. If it's true, I'm going to shade above. Oops, I moved my pencil. If this is true, I'm going to shade above my parabola. If this is false, I'm going to shade below my parabola. All right, 0 is greater than or equal to 0 squared is 0, 0 minus 1 is -1. That is true, so I want to include 0, 0. So if this is my parabola, I want to shade up here. Right, but where did they overlap? Here. So this is my feasible region. Okay, and that's my solution. I've graphed the system of inequalities. That area is my solution. Okay, thanks so much. Bye.